This is the wing of the first-generation Boeing 707 airliner. It has a wingspan of 39.9 meters. This is the wing of a Boeing 787. Its wingspan is 60.1 meters. And this is the wing of the in-service Boeing 777-300. It has a wingspan of 64.8 meters. Can you notice something? Airliners from different eras have wings that are getting longer and longer. Now, look at this. The new wings on the Boeing 777X. Its full wingspan reaches a staggering 71.8 meters. If you parked it on a highway, its wings could cover up to 20 standard lanes. You can clearly see that commercial aircraft wings are developing toward higher aspect ratios. So here's the question. Why are aircraft manufacturers so eager to make wings longer and longer? Today, let's talk about that. As usual, let's start with the answer. The core purpose is simple: to save fuel. Let's first look at how resistance works in flight. There are two main types of drag that an aircraft faces when flying forward. The first is parasitic drag, which comes from the aircraft body moving through the air. The second is induced drag, which is generated along with lift by the wings. If you compare flight to swimming in water, you might feel that parasitic drag is the biggest obstacle, since it affects the entire body. In contrast, induced drag only acts near the wingtips, so it seems less important. The airflow near the wingtip moves from the high-pressure region below to the low-pressure region above, forming a circular motion. It may look insignificant, but that assumption is wrong. In reality, during cruise, induced drag can account for 30 to 50% of total drag. During climb, it can reach as high as 80 to 90%. This happens because the high-pressure air beneath the wing rolls upward at the wingtips, forming powerful vortices. These vortices continuously pull the wings backward and create a downward airflow behind the wing. For the wing, this effectively tilts the lift vector slightly backward. Although lift is still generated, part of it becomes a rearward force. And that rearward component is what we call induced drag. In other words, aircraft are forced to use part of their thrust to fight against drag they create themselves. So how do engineers solve this problem? The answer is simple: make the wings longer. By extending the wings and increasing the aspect ratio, the wingtip vortices become weaker, which improves fuel efficiency. That's why manufacturers go to great lengths to make wings longer. But if higher aspect ratio is better, why not make wings infinitely long? The answer is no. First, in practical terms, airport infrastructure must be considered. If the wings are too long, the aircraft won't fit at standard gates. Most international airport stands have a maximum width of about 65 meters. Even beyond airport limitations, there are also technical constraints. Imagine holding a heavy object in one hand. If it's close to your body, it feels manageable. But if you fully extend your arm, the same weight creates much more stress on your shoulder. The same principle applies to aircraft wings. The outer wing acts like the weight, while the wing root is like your shoulder. Due to the square cube law, as wings get longer, both aerodynamic loads and structural weight increase rapidly. In turbulence, the outer wing may still perform well, but the stress at the wing root can become extremely high. This can exceed the limits of traditional aluminum structures. To counter this, engineers would need to add reinforcement, which increases weight and cancels out fuel savings. So, wing length must stay within an optimal balance to maximize efficiency. Infinitely long wings do not produce the best results. To solve both structural stress and airport compatibility issues, aircraft manufacturers have developed new solutions. One of the most innovative examples is the Boeing 777X. It uses advanced carbon fiber composites to build lighter and stronger wings. It also introduces folding wingtips. On the ground, the wingtips fold upward so the aircraft fits within airport limits. Before takeoff, they extend to the full 71.8 meters. With these technologies, the aircraft can operate flexibly on the ground while maintaining high efficiency in the air, reducing fuel consumption by at least 10%. So, that's the explanation why aircraft wings are getting longer. If you enjoyed this content, don't forget to like and subscribe.